Hello everyone and welcome back to Code with Vinay. Today we'll discuss how to determine whether a given number is a vampire number or not. As usual, we'll be developing a program that not only provides the correct answer, but does so efficiently and elegantly. Let us first start with the definition of the vampire number. Now, a vampire number is a composite natural number with an even number of digits that can be factored into two natural numbers, each with half as many digits as the original number, and where the two factors contain precisely all the digits of the original number in any order. Now let us understand this with the help of an example. The first vampire number is 1260, which can be expressed as a product of two numbers 21 into 60. Now the point to be noticed over here is that the vampire number contains even number of digits. So this is 4 digits, which is even. The second thing is it is a composite natural number, and obviously since it is expressed as a product of two numbers, it is a composite number, it's not prime. And the other point is that the two factors, in this case 21 into 60, contains the same digits as the original number. Notice 21. 1 is present in the original number, 2 is present in the original number. Similarly, 60. 6 is present in the original number and 0 is also present in the original number. Also notice that each factor contains half as many digits of the original number. That is, the original number was 1260, which means 4 digits, and each factor is of 2 digits each. Now let us begin with the coding, and I'll explain what I'm doing while I'm doing it. So I'll create a class, we'll call it vampire number, and then within that we'll have our main method, and our objective is to check whether a given number is a vampire number or not. So for that we'll make a method. We'll say public static boolean, and we'll give it some sensible name. Let's say is vampire number, and then we'll pass the variable, let's say number. And then let us make a test case also, and for that what we'll do is we'll check. We'll say system.out.println is vampire number, and let's check for the first vampire number, that is 1260. So the first thing is that a vampire number is a composite natural number. That means the number is not prime. So we need to check whether a number is prime or not, and for that we'll make a method. I'll say public static boolean is prime, and then we'll have the number, let's say int n. So this function will return true if the number n is prime, and it will return false if it is not a prime number. Now I have already done a detailed video on checking a number for prime, and you may want to go through that video in case you are having any doubts, and I'll share the link to that video in the description below. But since I'm going to implement the prime number testing logic for this program, I'll give you a quick recap of the logic, which I believe would be sufficient for most of you. So let's begin with is prime. So if the number is less than 2, it cannot be a prime number. So we'll simply say if n is less than 2, return false. Now 2 is the only even prime number, so we'll check for it explicitly. We'll say if n is equal to 2, we'll straight away say return true. If we are reaching line number 21, that is the current line, it means that the number is more than 2. And now we'll check that if n is even. Please note 2 is the only even prime number. If we are on this line, it means that the number is not 2. And if the number is not 2 and it is even, then it means that it is not a prime number. So we'll say that if n modulus 2 is equal to 0, that is if it is even and it is not 2, we'll say return false. And then we'll move on to our else block. Now, if we are in this else block, what does it mean? It means that the number is odd. But we know that all odd numbers are not prime. So what we do now, we need to check. Now, normally what students do, they take a loop from 1 till the number and then they decide whether or not it's a prime number. But here we want to write an efficient program. So what we'll do, instead of going till the number, we'll go till the square root only. Now, if you want to go into the details why till the square root, you are advised to watch the other video, the link of which will be shared in the description. So we'll say int math.sqrt n. So this is the limit till which we want to go. Now we'll again take a loop. We'll say int I is equal to 3. Please note we have already checked till 2. So we'll begin from 3. We'll go till our limit, that is the square root. And then we'll say I plus is equal to 2. Please note, since the number is odd, there is no point of dividing the number by even numbers. So we are starting from 3, and then instead of going to 4, we'll straight away divide by 5. Then instead of going to 6, we'll straight away divide by 7 and so on. And now, since we are not starting from the number, we are not going till the number. If there is any divisor in between, that means that number is not prime. So we'll say if n modulus I is equal to 0, that is, if there is any divisor I, we'll straight away say return false. And if our loop completes, that means the number is prime. So we'll say return true. So this is an efficient approach to checking whether or not a given number is a prime number. So now this takes care of the testing part of prime number. Now let us proceed. The next thing is that a vampire number contains an even number of digits. That is, we need to count the number of digits. And for that, we'll take a variable. I'll call it digit count. Initially, it will be equal to 0. Then I have to extract the digits one by one in order to count them. And for that, I'll take another loop. I'll say int temp is equal to the number. Then while temp is more than 0, we'll keep on removing the last digit. That is, we'll say temp is equal to temp divided by 10. And in order to count the number of digits, I'll simply say digit count plus plus. So this is going to count the number of digits. Just for the sake of understanding, let's print and see whether this is coming correctly or not. And for that, I'll just say print digit count. And since we are not returning anything from the function, we are getting an error. And in order to remove that error, I'll simply say return true. And I'll later on remove this line. So if I run this program right now, our number 1260 has 4 digits. Let's see whether this is working or not. So we'll go over here and we'll run the program. So we are getting 4 as the number of digits, which is correct. Now let's proceed. So what we'll do is we'll remove this line because this is no longer required. Now the thing is, we also have to store the number of digits of the original number. That is, which digit is occurring how many times, because we need to compare that with the digits in the factors later on. And for that, what we'll do is, in order to store the frequency of 10 digits, we can either create 10 different variables or we can simply create an array. And obviously creating an array is a better idea. So I'll say frequency, let's call it frequency of number. This is an array, so there will be a box bracket, and then we'll say new int. There are 10 digits, so we'll say 10. So we have created an array frequency number with the size 10, and the values will be 0 initially. Now what we need to do? We need to count. What I want to do is that the 0th location of the array frequency number should store the frequency of zeros. The first location should store the frequency of 1. The second location should store the frequency of 2, and so on. And for that, what we'll do is we'll simply say frequency number. We'll extract the digit, that is temp modulus 10. And then we'll simply say increase the corresponding location. Please convince yourself. Temp modulus 10 is the digit. We are extracting one digit at a time. So if the number is 1260, the first digit which will come out is 0. So the 0th location of the frequency number will be increased by 1. The next digit which will come out will be 6. So the 6th location of the frequency number will be incremented by 1, and so on. Let me print this for you so that it is clear. And for that I'll say import java.util.asterisk. I'm just importing this util class because I don't want to take a loop to print it. I'll simply say system.out.println, and then we'll convert the array into string and we'll print it directly, that is frequency of number. So now if I run this program, please note we are passing 1260. That means the first location of that array, the second location of the array, the 6th location of the array, and the 0th location of the array should be 1 because each digit is occurring once. So if I run this program, there we are. The 0th location, the first location, the second location, and the 6th location is 1. And just to confirm, let's say I add one more. I repeat one digit. Let's say I want to repeat 1. So now what should happen is that this location corresponding to the number 1 will become 2 because 1 is occurring twice. Let's run it again. So if I run it once more, there we are. This location is becoming 2. And then I'll just remove this one because again, this is no longer required. So this is how we calculate the frequency of digits. I'm going to remove this line also because this is only for understanding and not the part of the logic. Now let us proceed. So a vampire number is a composite natural number with an even number of digits. That is, if the number of digits are not even or the number is prime, the number is not a vampire number. So we'll first say that if digit count modulus 2 is equal to 1, that is, if the number of digits are odd or if the number is prime, we'll simply say return false. Now, I would like to point over here is that even if we do not write is prime number, the program is still going to work, but it will be quite slow. Now, the next thing is that we need to find the factors. We need to test for divisibility in order to find the factors. Now, the thing is from where to begin and where to end. So one thing is clear, that each of the factors should have half as many digits of the original number. So if the original number is having the digit count number of digits, our loop should run with the lowest number of half the digits. For example, if the number is 1260, the number of digits are 4. Half the value of 4 is 2. The smallest 2-digit number is 10. So our loop should begin from 10. And for that, what we'll do is we'll take one variable. We'll say int from divisor. I have to give it some sensible name. So I'll say from divisor is equal to, and then we need to find the smallest 2-digit number. And for that, what we'll do is we'll simply say int, and then we'll say math.power. And then we'll raise 10 to the required number of digits, and the required number of digits in this case is digit count divided by 2 minus 1. So this will give me the required number. So if the number is original number is a 4-digit number, half of 4 is 2, 2 minus 1 is 1, 10 to the power 1 is 10. Convince yourself for the bigger numbers also. So let's say we take a bigger number, in this case a 6-digit number. So the digit count will be 6. 6 divided by 2 will be 3. 3 minus 1 will be 2. 10 to the power 2 is 100. And 100 is a 3-digit number. So we see that our from divisor variable is working properly. And now we have to find the upper limit. And for that, we'll take a variable to divisor, that till where we want to take the loop to. And while you might think that a better idea will be to simply find the highest number with the digit count equal to digit count divided by 2, please understand that's not efficient. Why? Because whenever you have two factors, that is, if there is a number, let's say 1260, the two factors in this case are 21 into 60. Something multiplied by something will give you the product. So there is no need to take the value till the maximum number of digits. We can simply take it till the square root, because if there are two factors, one of them will be less than or equal to the square root, other will be more than or equal to the square root. It won't be that both of them are on one side. So we'll say add dot sqrt the number, which is number. Now the next step is to take a loop from the variable from divisor to the variable to divisor to check for divisibility, and for that we'll say int, let's say divisor is equal to from divisor, and the loop will run while divisor is less than equal to divisor, and then we'll say that okay, divisor plus plus. Now we have to check for divisibility. So for that, what we'll do is we'll say if the number modulus divisor, if it is equal to 0, that means we have found one pair of divisors. So for the sake of better understanding, let us display the pair of divisors which we have found. And for that, what we'll do is we'll say system.out.println. Obviously, number modulus divisor is equal to 0. So one divisor is stored in the variable divisor, and the other divisor is number divided by divisor. So let's run this program once and see what happens. And as you might be remembering, our input is 1260. So let's run this. So if I run the program right now, there we are getting the factors, that is 10 into 126, 12 into 105, 14 into 90, and so on. Now the point to be noted over here is that all composite numbers will have some factors, but vampire numbers will have factors having the same digits as the number itself. That means now we have to again prepare a frequency table of the digits of the factors. Also recall that the two factors cannot both have trailing zeros. That means if both the factors are ending with a 0, we'll skip that combination. So let's proceed. So we'll go over here. Again, we need not print it. So what I'll do is I'll simply comment it for the time being. I'll remove it later. And then let's check for the trailing zeros. That is, if both the factors, that is, if divisor is ending with a 0 and number by divisor is ending with a 0, we'll skip the combination. So if divisor modulus 10 is equal to 0, that means if the first factor, that is divisor, is ending with 0 and number divided by divisor modulus 10 is equal to 0, then we'll skip the combination. We'll simply say continue and we'll proceed on with the next set of divisors. Now we have to handle the frequency of the factors, which is essentially the same thing what we did earlier. That is, I'm talking about this portion. So what I'll do is I'll simply copy this and then we'll change the variable names to speed things up. So we'll say over here, let me indent it properly. So we'll say frequency of factor, and then the number will not be equal to number right now. It will be equal to the divisor. We don't need the digit count, so we'll get rid of this digit count. And since there is only one line, we can even get rid of this curly braces. Now the same thing needs to be done for the second factor also. So I'll again copy it. We'll paste it. And again, we have to correct the indentation. For that, I'll press backspace. And instead of divisor, we have to take care of the second factor, that is number divided by divisor. So here I'll say number divided by divisor. So this first loop will count the digits of the first factor. The second loop will count the digits of the second factor, just like we were doing earlier. One more change which is required is that we have to change the name of the array at both the places. It shouldn't be frequency number now, it should be frequency factor over here as well as over here. Now, once this is done, that is, we have calculated the frequency of both the factors, we have to check whether this array is identical to the earlier array. That is, frequency of number must be exactly equal to frequency of factors if the number is a vampire number. If there is a mismatch at even one location, we know that the number is not a vampire number. Or rather that those two factors do not form a vampire number. So now what we'll do is we have to check for the arrays, and for that let's take a boolean variable. I'll say boolean, let's call it digits okay, because that is what we are doing. We are checking whether the digits are okay or not. So initially we'll say that they are equal. If they are not equal, we'll make it false, and for that let's take a loop. We'll have to take the loop for each digit. So I is equal to 0, I is less than 10, I plus plus. One by one we'll iterate through all the 10 positions, and if the frequency of the number array is not equal to the frequency of the factor array for any I, we'll say that digits okay is equal to false. And once we know that it is false, there is no point in continuing and checking for the rest of the digits. So we'll say break. And once you are out of the loop, that is, once we are at this position, now there are two things. Either the digits are okay or the digits are not okay. So if the digits are not okay, we'll proceed with the next iteration. So if digits not okay, we'll simply say continue. Otherwise, we'll have to take one variable for storing the final answer, and for that I'll say boolean status is equal to false. Initially we don't know what the state is, so we'll say it is false. And if the digits are okay and we are in the else block, we'll say that status is equal to true, and then we'll break. And outside the loop where we had true right now, we'll say status. Now let us run the program to see the output. So if I run the program, we are getting true. The input was 1260, which is correct. Now let me copy this once more and let's change it to something else, 1265. We know that that is not a vampire number, so now we should get a false. Let's run it once more. So there we are getting a false now. And let's, for the sake of completeness, let us use this function to generate the list of first few vampire numbers and see whether we are getting the same vampire numbers or not. So for that, what we'll do is I'll simply take a loop from 1260 till this number and see what happens. So we'll go down. I'll remove these two print statements and we'll run a loop. We'll say int I is equal to 1260. I is less than equal to the last one in our list. Then we'll say I plus plus. And then we'll check if is vampire number I. We'll say system.out.print I. Will display one space in the end so that it looks better. And when finally all the numbers are printed, we'll say system.out.println to give a blank line. So now if I run, we should get a list of vampire numbers. Let's see, what do we get? We are getting 1260, 1395, 1435 and so on. We'll go up and we'll just give a check. So yes, we are getting the same list, which proves that our program is right. So this is how we write an efficient and elegant program which tests for a number being a vampire number or not. So that's all for this video. See you in the next video. Thank you. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.